Okay, more cuboids. We've already had a video on cuboids, but there was one or two things I wanted to cover which are important. Notice in some exam questions, they ask for the volume in litres, okay? And for that, you need to remember this, right? It's really important. It's probably going to come up in the exam, isn't it? Because it seems to come up in a lot of questions. You just need to remember 1 litre is 1,000 centimetre cubed, okay? So often, you'll get your answer in centimetre cubed, and you need to work out then how many litres are in there. Okay, so please remember this, it's really important, right? So write it down somewhere, okay, and memorise it. 1 litre is 1,000 centimetre cubed. Now if we look at number question 1 here, it says, an open rectangular water tank has dimensions as follows, shown below. What's the volume of the water in the tank when it's completely filled? Now they want it in cubic metres, right, which is metres cubed. The reason why I put this question here because when you do the volume, of course it's length times width times height. The length is 3, the width is 2. Of course the height, be careful there, they put it in terms of centimetres. So you need to write that in terms of metres in this case. If you think of 1 metre is 100 centimetres, so 50 centimetres will be half a metre. Okay, so put it in terms of metres because they want it, don't they? They want it in metre cubed. So change this, so it's in terms of metres this time, right? So 0.5, and if you work that out, you actually get 3. That's the answer, 3 metre cubed. Okay? Right, question 2. This is what I was talking about at the start of the video. Water is poured into an empty rectangular tank of length 15, width 10 and height 12 until the tank is full. Calculate the volume in litres, okay? Now, water is often measured in litres, isn't it? So that's why sometimes they'll ask for the volume in litres. But you go about it the same way, right? You still do length times width, okay, times height, and it'll still be 15 times 10 times 12. You still do that, right? Now, this question was actually in a non-calculator paper, so I'm going to have to do this without a calculator. Of course, length times width times height, well, I can do 15 times 10, can't I? Okay, 15 times 10 straight away, that's 150. Maybe I'll break it down. Okay, so 15 times 10 is 150, and now I need to times it by 12. So all I've done is I've just worked that out, haven't I? 150 times 12. Well, perhaps what we could do is do 150, I'll do it by the side here, times 10, and 150 times 2. Okay? Just different strategies really. You don't have to use the same strategy all the time, but different strategies to actually help you work out something like this. So if I wanted to do 150 times 12, first of all times it by 10, which is 1500, add a 0, and then times it by 2, which is 300. So all together then, you put them together, you've got 12 lots, haven't you? So that's 1800. Okay, so it's 1800. Now that's centimetre cubed, okay, but they want litres. Now given 1 litre is 1,000 centimetre cubed, okay, write it down in the exam. Write this down because you might get a mark just for writing that down. How many thousands are in there? Well, you've got 1, haven't you? You haven't got more than 1. You've got 1, and then you've got 800 centimetre cubed. So it'll be 1 whole litre, and you'd write that then 1.8, wouldn't you? 1.8 litres. Okay, this one, a storage container in the shape of a cuboid measures 20 by 10 by 25. Calculate the volume of the container, indicating the units in your answer. So, here, again, length times width times height. Okay, so this is a calculator question from a calculator paper. So you do that and you get 5,000 centimetre cubed. Okay, when you work that out, 5,000 centimetre cubed. Part B, the container is used to store 4 litres of cooking oil. Calculate the distance of the surface of the cooking oil below the top of the container. Okay, so oil is poured in here, right? 4 litres of it. If you think about it, the container is that, isn't it? That's the volume. And that's 5 litres, isn't it, if you think about it? So when you pour the oil in here, it's not going to reach the top. Okay? It's not going to quite reach the top, isn't it? Because it's only 4 litres. So we need to work out the distance. What does it say? The distance of the surface of the cooking oil below the top of the container. They actually want this, don't they? That's what they want. The distance of the surface of the cooking oil below the top of the container. They want that. What I'm going to do though, I'm going to just work out this first. Okay, I'll call that H. If I can work that out, I'm sorted. With the oil, even though it's not to the top, it's still forming a cuboid. So the volume would be 20 times 10 times H, wouldn't it? Yeah? Length times width times height. But of course I know what that equals to. I know what the volume is. It's 4 litres. It's 4,000, isn't it? 4,000. So if I work that out, 20 times 10 is 200. Times H is 4,000. So I end up having H equals 4,000 divided by 200. Okay? So take it over and divide. Now of course the zeros cancel and I'm left with 20. H is 20, which means that distance there is going to be 5, isn't it? So the distance is 5 centimetres.